Hey there, in this video we're going to learn how to solve radical equations. And in a mathematical context, this word radical refers to a root. So something like a square root or a cube root or a fourth root and so on. And in this video we'll focus mainly on just square roots, but these same methods will work for any type of general radical equation. So here's an example of a radical equation. 4 plus the square root of x minus 10 is equal to 7. And what we want to do when we are solving an equation is we're trying to figure out what value of the variable makes this equation true. What does x equal? And if you're familiar with solving other types of equations, like linear equations, you probably already know many of the tools that we'll use here. What we want to do is use inverse operations to move things over to the other side of our equal sign until eventually we're just left with x by itself equal to some number. But there's an order that we want to do this in when we're using our inverse operations. We want to work from the outside in. So we want to start with things that are outside of our square root and then continue and work with what's inside the square root. So our first step here is we want to get the radical part of this equation by itself. And the technique to do that is we can use inverse operations to move terms over to the other side of our equals sign. An inverse operation is something that essentially cancels out two things that are opposites of each other. So the inverse operation we can use to cancel out this plus 4 is if we subtract 4. 4 minus 4 is equal to 0. And we have to do the same operation on the other side of our equal sign so that we're not changing the overall balance of this equation. So when we do that, 4 minus 4 cancels out. And we're left with square root of x minus 10 equal to 7 minus 4 gives us positive 3. So we've taken care of everything that we can outside of our radical, and now it's time to figure out how we can get rid of this radical so that we can deal with this nice juicy center inside the x minus 10. To get rid of a square root, there's an inverse operation we can use. The opposite of a square root is a square. So we're going to square both sides of the equal sign. And when we square something that's inside a square root, those are inverse operations. So that cancels out our radical. So we're just left with x minus 10 by itself equal to 3 squared is 3 times 3, which gives us positive 9. After we've gotten rid of the radical, there might be some terms left over that were inside of our radical originally that we should still continue with when we're solving. So now we want to solve for our variable, again using inverse operations to move things to the other side of our equal sign. If we add 10 to both sides of this equation, negative 10 plus 10 cancels out and we're left with x equal to 9 plus 10, which gives us 19. So let's keep practicing this method with some more examples. We'll start with this example that's on the top left, And we want to take care of anything that is outside of our radical first, isolating the square root part of this equation. So I see we've got this -5 that is outside of our radical. We have to be a little careful, though, about the correct inverse operation that we can use to cause that -5 to cancel out, because your eyes see this minus sign and you're thinking, well, that looks sort of like subtraction. But this is not something that is being subtracted with our radical. When we write a number right next to the radical like that, that number is a coefficient. What this really means is -5 times the square root of 4x. So the inverse operation that we can use to cancel out that -5 is we want to divide both sides. Oh, that handwriting is atrocious. Just for the sake of everybody, let me write that one more time. Let's divide both sides by -5. That's what will cause this multiplication to cancel out. So when we divide -5 by -5, that's 1, and we're just left with square root of 4x. And -30 divided by -5 gives us +6. So we've gotten rid of everything that was outside of our radical. Now we're ready to move on to our second step and square both sides of the equation. That will cause the radical to cancel out because a square root and a square are inverse operations of each other. So we're just left with 4x equals, and 6 squared is 6 times 6, which is 36. Now that there's no more radical in this equation, we can get our variable by itself and solve for x. And once again, we have a coefficient. This 4 times x means we need to divide both sides by 4 to cause that to cancel out. So we have x by itself is equal to 36 divided by 4, which gives us 9. In this next example, we can see that we have a fraction on the side of our equal sign that has the radical. So first thing we should do is figure out how we can get rid of that fraction. Well, if we want to cancel out a fraction, we can remember that a fraction just means division. So we can multiply both sides by the denominator of our fraction. If we multiply everything on this side of the equation by 3, we have 3 in the numerator and 3 in the denominator, which cancels out, and we can also multiply this 2 by 3. And to give ourselves a little more room to work, let's continue this on the next screen. And I want to just clarify again that when I'm multiplying by 3 in the numerator, we say we're multiplying, but there's nothing that we need to calculate on this side of our equation. We do not need to multiply, for example, this 3 times -1, because we have a 3 in the denominator that cancels out with this 3. So the reason we multiplied by 3 was just so we could have something that would cause this fraction to cancel out. But we do still need to multiply by 3 on the other side of our equal sign. So we got rid of our fraction, and we still have square root of 6x plus 7 minus 1 is equal to 2 times 3, which is 6. Now there's another term outside of our square root that we're going to need to move over to the other side of our equal sign before we can deal with what's inside the radical. This minus 1 is something that is being subtracted from our square root. So the inverse operation that will cancel that out is if we add 1 to both sides, and we get square root of 6x plus 7 equals 6 plus 1, which is 7. So we've taken care of the first step, which is to get rid of anything that is outside of the square root. Now we want to get rid of the square root so that we are just dealing with what's left over inside. And to get rid of the square root, we can square both sides of the equation. A square root squared cancels out, those are inverse operations. So we have 6x plus 7 equals 7 squared, that's 7 times 7, which is 49. Now we're ready to solve for x and figure out what this variable equals. If we have a coefficient as well as a number that we're adding or subtracting in our equation, I would recommend that you do the subtraction first before we do the division. And the reason for that is, if I want to divide by 6 to get that 6 to cancel out, but we still have this 7 on that side of our equation, I would also need to divide 7 by 6, which would give us the fraction 7 over 6. And we could continue solving the problem using fractions, but if possible, it's going to be a little easier for us if we avoid creating fractions when we don't need to. So let's do the subtraction before we divide. If we subtract 7 from both sides, that gives us 6x equal to 49 minus 7, which is 42. And now when we divide both sides of our equal sign by 6, 42 divided by 6 works out evenly, and we get our final answer, x is equal to 7. So now let's do another example that looks a little different from the previous ones, because now we have radicals on both sides of our equal sign. But that's all right, we can still apply the same technique and square both sides of our equal sign in order to cancel out those radicals. So if we square both sides, that will cause both of the radicals to cancel out, and we're just left with the terms that were underneath. Negative 11x minus 23 equals 17 minus 3x. To solve an equation like this that has variables on both sides of our equal sign, what we want to do is move all of the variables to the same side of our equal sign. So we could pick either side, and why don't we try to move this negative 3x over to this side of our equal sign. So in order to do that, we can add 3x to both sides of the equation. Negative 3x plus 3x will cancel out. And when we have negative 11x plus 3x on that other side, that gives us negative 8x. So that's helpful because that takes these two like terms that were on opposite sides of our equation, moves them over to the same side so that we're just dealing with one copy of our variable, so that eventually we can figure out what that one copy of x equals. Now we want to move all of the numbers in our equation other than x to the other side of our equal sign. And then we'll just be left with the variable x by itself. So if we add 23 to both sides of the equation here, 17 plus 23 gives us 40. And negative 23 plus 23 is 0, so those cancel out. Negative 8x equals 40, and we can solve that if we divide both sides of this equation by negative 8, and we're left with our final answer, x is equal to negative 5. So if you're feeling comfortable with this method and you want to get right to practicing, I encourage you to do more practice. I'm also going to post another video working through some more examples if you'd like to see those first.